coagulation or the precipitation, it is one and the same. It is a process of settling of the colloidal particle. If the fluctuating ions will having the greater valency means greater will be the precipitation formation. What is emulsion? Emulsion is a kind of colloidal solution where both the dispersion phase and dispersion mediums are exist in a liquid state. There will be a settlement of the charges will be taking place in the colloidal solution, leading to the formation of coagulation. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Surface Chemistry. Under that, we have discussed about the properties of colloidal solution. In that, we have listed out the 4 different properties, that is the Tyndall effect, Brownian movement, color, as well as with the colligative property. In addition to this, we also talk about the charges on the colloidal particles, and we have discussed about the Helmholtz electrical double layer, and also we talk about the electrophoresis. Today, let us move on to the next topic of this unit about the coagulation and precipitation. And we are going to understand with the Hardy-Schild rule and emulsion and colloids which is present in our surrounding, and lastly the application of colloids. Let's see what is a coagulation and what is a precipitation. Coagulation or the precipitation, it is one and the same. It is a process of settling of the colloidal particle, which means to say that we know that colloidal particles will having some charges. It may be a positive in nature or it may be in the negative in manner. In order to neutralize the charges which is present in a colloidal particle, we go for the coagulation. So what is a coagulation? It is a process of neutralizing the charges which is present on the colloidal particle. Or you can say that it is a process of settling of colloidal particle. It is said to be coagulation or precipitation. The coagulation of lyophobic salts can be carried out with the following ways. The first one is by electrophoresis. Already we have learned that what is an electrophoresis. Is it right? So in the electrophoresis, they will take the U-tube and they will consist of the platinum electrode, and they will put the colloidal solution to that U-tube. So when you apply the electrical field, the colloidal particles which are having the opposite charges will be moved towards the respective electrode. Is it right? In our last lesson only we have learned this experiment. So in this, they will fill the colloidal solution in such a way that when you apply the electrical field, suppose if the colloidal solution which consists of the negative charges will move towards the cathode. Similarly, if the colloidal solution which consists of positive charges will be moved towards the anode. This is how by doing the electrolysis we can settle out the colloidal solution. So colloidal particles will be moved towards a move towards oppositive charge electrode and get discharged, and later it will be get precipitated. So this is the first method. And the second method is by mixing the two oppositively charged salts. Suppose if your colloidal solution which consists of the positive charges will mixed with the oppositive charged particle. It may be, for example, your colloidal solution which having a positive charge, to that we are going to mix with the negatively charged particles of the salt. This is how by mixing the two different charges to the colloidal solution, we can settle down the colloidal particles. So oppositively charged salts are mixed in almost in an equal proportion and neutralizes the charges and get the partially or completely precipitated. This type of coagulation, which is also known as mutual coagulation. So here also in this mutual coagulation, already we have learned that colloidal particles will having a charges. It may be positive in nature or it may be negative in nature. For the positive colloid, if you add the negatively charged sol, the charges will be get neutralized. Such kind of coagulations are known as mutual coagulation. Example is by mixing the hydrated ferric oxide, which is a positive salt, and arsenous sulfide, which is a negative salt, then precipitate will be get formed. This is how the positive salt and the negative salt, when you mix, charges will be get equal and leads in the formation of precipitation or the coagulation. This is how we can easily neutralize the colloidal particle by two methods. First one is electrophoresis, then by adding the oppositively charged salt. There is another method called as boiling. What does it mean? When you boil the colloidal solution, we know that adsorbent will be get disturbed. Is it right? When you boil the salt, the adsorbent layer will be get disturbed, and due to this, increased collision with the molecules of dispersion medium will be taking place, and this reduces the charges on particle and ultimately leading to the settle down of the colloidal particles. When you heat the colloidal solution, the adsorbent which is present in the colloidal solution will be get disturbed. Once it will get disturbed, the process of collision of the molecules will be get increases as you increase the temperature by boiling. So that after that, there will be a settlement of the charges will be taking place in the colloidal solution, leading to the formation of coagulation. This is another way. And there is one more method known as by persistent dialysis, which means to say that if you do the dialysis continuously, even the small quantity of the electrolyte, if it is there in your colloidal solution, which will be completely removed out, so that the entire colloidal solution will be get settled out, or it will be become stable, or you can say that it will become neutralized. Okay. So on prolonged dialysis, the traces of electrolyte present in the salt will be removed completely and the colloids are become unstable. And you can say that the colloids will be become stable and it is get neutralized completely when you do the prolonged dialysis. And by adding the electrolyte, already we have understood that small quantity of the electrolyte which is added to the colloidal solution to increases the precipitation formation. Is it right? Then when you add the large quantity of the electrolyte, how does it will be get neutralized? Let us see now. When excess of electrolyte is added, colloidal particles are get precipitated. The reason is that colloids are interact with the ions which are carrying the oppositive charges that are present on themselves, and this causes a neutralization leading into the coagulation. Here we are adding the excess of electrolyte to coagulate the colloidal solution or to form a precipitation in the colloidal solution. Hence that electrolyte are also known as coagulating ion. They are said to be coagulating ion. So even if you add a large quantity of the electrolyte to the colloidal solution, it will increases the precipitation formation. Once the precipitate which is formed in a colloidal solution, the charges which is present in the colloidal solution will be attracted towards the oppositive charges of the electrolyte and forms the neutral charges in the colloidal solution. This is how by adding the excess quantity of the electrolyte by boiling, by electrophoresis, and also by adding oppositively charged salts, we can coagulate or we can settle down the colloidal solution, or we can say that we can neutralize the charges which is present in the colloidal solution. Hope you all understood with the coagulation and precipitation. We'll move on to the next topic. Next topic is Hardy-Schild rule. What does it mean? Let's see now. greater the valency of the fluctuating ions are added, greater will be the power to cause the precipitation. This is known as Hardy-Schild rule. The coagulating power of electrolyte increases with increasing the charge due to the coagulation, which means to say that greater the valency which is present in the coagulating ions, which is nothing but an electrolyte, okay, greater will be the process of formation of precipitation. What does it mean? We know that we have aluminium 3 plus, then sodium plus or magnesium 2 plus. All these ions will having a greater valency. The valency of aluminium is 3, valency of the sodium is 1, valency of magnesium is 2. Or you can say barium also. It will be also having a +2 oxidation state, or the valency of the barium is +2. Greater the valency of this fluctuating ions, greater will be the coagulation. If the electrolyte will having the greater valence, that will coagulate the particles which is present in the colloidal particles to the great extent, so that the process of coagulations will be get increased, or we can say that the process of precipitation formations will be get increases. That is why the aluminium will be having more valency as compared with the barium as well as with the sodium. So this can be used for negatively charged colloidal particle, because if the colloidal particle is negative, it will be attracted toward the positively charged salt. That is why I have listed out some of the positively charged coagulating ions which will coagulate the colloidal particles. I have another sets of ions where FeCN6 4 minus, PO4 3 minus, SO4 2 minus and Cl minus. These are negatively charged coagulating ions which will be used for positively charged colloidal particle, because the oppositive charges were attracting to each other. So like this, greater the valency of fluctuating ions, greater will be the process of precipitation, and this idea was given by Hardy and Schild, hence it is named as Hardy-Schild rule. So hope you are understood with this. Always remember, if the fluctuating ions will having the greater valency means greater will be the precipitation formation. Similarly here also FeCN6 4 minus will be having the greater valency, that will form a more precipitation as it compares with the Cl. So hope you are understood with this concept. Next we will see with the coagulation of lyophilic colloids. So already we have understood that how the coagulations will be done in the lyophobic colloids. Now we are going to understand coagulation in the lyophilic salts or in the lyophilic colloids. There are two factors which are responsible for the stability of lyophilic colloids. What is lyophilic? Lyo means solvent and philic means loving. They are the solvent loving colloidal solution. Is it right? There are two factors which mainly determine the stability of this lyophilic salts. The first one is charges and solvation of colloidal particle. When these two factors are removed, lyophilic salts can also be get coagulated. When these two factors are removed from the lyophilic salts, we can form precipitations in a lyophilic colloidal solution also. So that can be done by adding a suitable electrolyte and also by adding a suitable solvent. So by adding the suitable solvent which will neutralize the charges in the lyophilic salts, as well as by adding the suitable electrolyte, which is nothing but a coagulating ion or coagulating ion, which will neutralize the charges which is present in lyophilic salts. This is how the coagulations or the precipitations which is also done in a lyophilic salts. Only thing is we need to remove the two important factors. One is charge and another is solutions of the colloidal particle. And last topic is protection of colloids. How to do the protection of colloids? Let's see now. When a lyophilic salts are added to the lyophobic salt particles forms a layer around the lyophobic particles. Thus, it will protect the layer from the electrolyte, and lyophilic colloids are used for this purpose. So, if you are having a lyophobic salts, to this, if you add the lyophilic salts, this lyophilic salts which forms a outer layer or the protective layer to the lyophobic salts. For this protection of the lyophobic salts, we are using the lyophilic salts, hence it is also known as protective colloids. This is how the protection of the colloids which also done by using lyophilic salts, because the lyophilic salts which forms a protective layer around the lyophobic salts. Next one is emulsion. Let's see what is the emulsion and how does it will be formed. Emulsions are the special type of colloidal solution in which both dispersion medium and the dispersion phase are in the liquid state. So, what is the emulsion? Emulsion, it is nothing but a colloidal solution, okay, in which dispersion phase and the dispersion medium both will be exits in the liquid state, okay. If a mixture of two immiscible or partially miscible liquids are shaken, the coarse dispersion of one liquid in another will be obtained, which is known as emulsion. So, for example, I can give you the example of water and oil. We know that water and oil are immiscible liquids. They do not mix each other. So, when you mix these two liquids, it will form a layers that lead into the formation of emulsion. So, what is emulsion? Emulsion is a kind of colloidal solution where both the dispersion phase and dispersion mediums are exits in a liquid state. Example, two immiscible liquids are nothing but water and oil. The water and oil which forms a colloidal solution where it is not mixed with each other. That is the example for the emulsion, and there are two types of emulsions will be there. The first one is oil dispersed in water and water will be dispersed in oil. So, what is then oil dispersed in water? When the oil is the dispersion phase and water is a dispersion medium. For example, milk is an example for that. Oil water or oil dispersed water. You can see that oil in water and another one is water in oil. In this oil in water, we know that oil itself will be act as dispersion phase. Oil itself will be act like a dispersion phase, whereas the water molecules will be act like a dispersion medium. Whereas in water dispersion in oil, here the water will be act like a dispersion phase and oil will be in the dispersion medium. This is how we can understand the two types of emulsion. What are the two types? The first one is oil dispersed in water and water dispersed in oil. In a oil dispersed in water type, oil itself will be act as a dispersion phase and water will be become a dispersion medium. Example is milk. For example, if you add the milks to the water, this will become an example for the oil and the water type. Whereas water dispersion in oil, water itself will be act like a dispersion phase and oil will be act like a dispersion medium. Example is butter. This is how the special type of the colloidal solution which is also named as emulsion and their types. Next one is emulsifying agent. Now we have understood that what is an emulsion. Let's see what is an emulsifying agent. The substances which are added to neutralize the emulsion are known as emulsifying agent. Once the emulsions which is formed, we need to neutralize it. That can be done by using some of the substances are known as emulsifying agent. Examples are protein, gums, natural and synthetic soaps are used as a emulsifying agents. And heavy metal salts of fatty acids and a long chain of alcohols and lamp black. These are some of the substances which will be used as a emulsifying agent. Next one is colloids around us. So now you have understood that how the coagulations will be done for the lyophilic colloids, how the coagulation will be done for the lyophobic colloids, and also we have understood that what is an emulsion and what is a emulsifying agent. Now we are going to understand where the colloidal particles or the colloidal solution will be exits in our surrounding. In the blue color of the sky, we all know that the sky will be looks blue. That is mainly because of scattering of the light with the particles. Is it right? The scattering of the light with the particles which is present in our surrounding, which makes to looks the sky to become blue to our eyes. So the dust particles along with the water which is suspended in the air, which will be scatter the light and reaches our eyes. That is why the sky will be looks blue in color. This is the first example for the colloids which is present in our surrounding. And next one is the fog, mist and rain. How does it forms? We know that when a large mass of air which are containing a dust particle, when they cooled below the dew point, the moisture from the air condenses on the surface of these particles and forming a fine droplet. And these droplets are being colloidal in nature. They continue to float in the air and leads into the formation of fog or the mist. So this is how the fog and the mist, which also become an example for the colloidal solutions or the colloids which has been formed in our surrounding. How does it form? Due to the dust particle and the temperature is very low at a dew point, which makes the water droplet to condense back and to settle down in the formation of fog as well as with the mist. And next one is the clouds. We all know that are aerosols which are having a smaller droplets. We all know that how the clouds will be formed. Due to the evaporations of the water from the sea level, it will be forms of tiny droplets. When these tiny droplets, when it is reaches with the air, it will become a aerosol. When they are accumulated, it will become a bigger in size. When they become heavy, it again comes back to the earth in the form of rainfall. This is how, the rainfall which is reaches to the earth and the formation of fog and mist, which is the best example for the colloids which has been formed in our surrounding. And some of the food articles such as the milk, butter and halwa, ice cream, fruit juices are the example for the colloidal solutions which is there in our daily life. And next one is in the blood. So it is a colloidal solution of aluminoid substances and alum and ferric chloride exhibit the stypic action. This is due to the coagulation of the blood which are forming a clot by alum and a ferric chloride. Suppose you would have seen that when we are get an accident, suddenly when we reaches to the hospital, in order to avoid the overflow of the blood, they'll add the alum to the affected area. When you add the alum to the affected area, that will coagulate the blood so that overflow of the blood will be get stopped. So overflow of the blood will be get stopped due to the addition of alum, which is nothing but an electrolyte which is added to our body to avoid the overflow of the blood because it forms coagulations in the blood. This is another example for the colloids which is also formed in our life. Next is soil. Fertile soils are colloidal in nature which consists of humus which act like a protective colloid. So we all know that the soil is very important for the human life to grow a innumerable number of crops. Is it right? And the soil itself will be acts like a colloidal in nature because it consists of the humus which is act like a protective layers to the soil. Okay. And next one is formation of delta. The river water is a colloidal solution of clay and the sea water which consists of many number of electrolytes. When a river water meets the sea water, electrolyte present in the sea water coagulate with the colloidal solution of the clay, resulting in a deposition or the formations of delta. You would have seen with this picture in a TV, where the rivers and the sea, when they are meets with each other, relates into formation of delta. So what does it mean? Again, this is an example for the colloidal solution. We all know that river water will be consists of clay and sand, and this sea water will be consists of innumerable number of salts, especially which are very rich in electrolyte, we can say. When the river water and the sea water mixes with each other, already we know that sea water will be consist of electrolyte. It will coagulate the river water, thereby it forming a formation of or the deposition of delta. So this is another example for the colloids which is also formed in our daily life. Hope you all understood with the colloids around us. Next one is applications of colloids. So where we are using these colloids, let's see now. Colloids are widely used in industry with the following example I have listed out. By electrical precipitation of smokes. The smoke is a colloidal solution of solid particles such as carbon and arsenic compounds and a dust, etc. In the air, the smoke before it comes out from the chimney and lead through the chamber which consists of plates having a charge opposite to that of the smoke particle, and particles are coming out with this contact with these plates loses their charge and they get precipitated, and these particles are later settled down at the floor of the chamber and precipitator will be used for this, and it is known as coral precipitator. So you would have seen with the industries, they always used to throw the waste materials in the form of fumes. So in the form of smoke, they usually release as a innumerable number of smokes to the air. We know that when these smokes, when we inhale, even we get a respiratory problem, and it is also causes a air pollution. That is why nowadays, this smokes before reaches to the air, they'll do the filtration. How they'll do? They'll have a separate chamber for this. They'll allow the smokes to pass through it, and they'll place the different kinds of plate in this chamber. When smoke is passed through this chamber, whatever the smoke and the dust particles which is there, it will be settled down on the plates, and remaining smoke will be released to the environment, which is not so harmful. This is how, by using electrical precipitations of the smoke, they will avoid the dangerous gas enters into the air. And next one is by purifications of drinking water. The water which is obtained from the natural sources are often contain the suspended impurities. Alum will be added to such water to coagulate with the suspended impurities and make the water fit for the drinking purpose. Especially in the villages, when they are wanted to get the water, they'll add the alum to the water in order to remove the suspended particles which is there in the water itself. Thereby, the water will become fit for drinking purposes. This is another example for the applications of colloidal solution in our daily life. And next one is medicine. Most of the medicines are colloidal in nature. For example, argyrol is a silver salt used as an eye lotion, and colloidal antimony will be used for curing the Kala-azar, and colloidal gold will be used for intramuscular injection, and we are familiar with the milk of magnesia will be given to the indigestion. So these almost all the medicines, they are also in colloidal nature. Why they are colloidal in nature? Because when we take those medicine, it will quickly remove the pain, or quickly it will cure the infections which is present in our body. It quickly relieves from the pain. And next one is in the tannin. The animal hides are colloidal in nature when the hides which has positively charged particle which is soaked in tannin, which consists of negatively charged colloidal particle, mutual coagulations will be taking place, results in hardening of leather. So, in the preparations of the leather also, they'll take the animal hide and they'll dip in tannin. So, these two are oppositely charged colloidal particle. They forms a mutual coagulation, results in hardening of the leather. This is how in the preparations of the leather also, they'll go for the coagulation. This process, which is also known as tanning, and the chromium salts will be generally used for the tanning. And next one is cleansing agents or the cleansing action of soaps and detergent. Already I have explained that how the cleansing actions will be done by the soaps and detergent, especially to remove the grease and dirt which is there in your cloth. And next one is photographic plates and films. Photographic plates or the films are prepared by clotting the emulsion of light sensitive to the silver bromide in the gelatin over the glass plate or with the celluloid films. In the preparations of photographic plates also, we use the colloidal solutions. And in the rubber industry, especially the latex is a colloidal in nature. This rubber particles which are negatively charged, and this is obtained by coagulations of the latex. We know that latex will be obtained from the bark of the tree, that itself will be act like a coagulating agent because it will be used in a preparations of synthetic rubber also. Next comes to the industrial product. We all familiar with the paints as well as with the ink and the plastic, rubber, graphite and the lubricant and the cement. They are usually in the colloidal solution. So this is all about the applications of colloids, colloids in our surrounding, coagulations and coagulating ions, and also with the precipitation. Hope you all understood with this session. In the next session, we are going to start with another new unit which is there in your second PU. Till then, take care, be safe. We'll meet you in the next session. Thank you.